Cattle Point is located on the southern tip of San Juan Island. This conservation area is managed by the Washington Department of Natural Resources and spans a little over 100 acres. The lighthouse was built in 1935 and recently restored. Glaciers helped shape the geology of this area. The substrate is rocky. Cobble, meaning rocks roughly the size of your head to the size of your fist in some places, and bedrock, or a wide, flat expanse of rock in others. There are also some areas of smaller particles like sand and gravel. Cattle Point also has a range of wave exposure levels. The part of the beach that is farthest south is more protected, meaning it experiences less wave activity, whereas the shores around the corner and past the lighthouse are more exposed with greater wave activity. Just offshore, you can see a bed of bull kelp, Nereocystis luciana. These are important habitat-forming foundation species. Different tidal heights on the rocky shore are home to different organisms. We call this pattern zonation. Intertidal organisms have special adaptations that allow them to persist both when covered by water and when exposed to air. Organisms that live higher in the intertidal are exposed to air for more of a tidal cycle and have adaptations that allow them to cope with associated stressors like drying out or being exposed to the sun. Here in the Salish Sea, we have mixed semi-diurnal tides, meaning 2 high tides and 2 low tides per day, each with different heights. This time of year, our low tides happen to be at night, meaning that intertidal organisms are not getting too much sun or getting too hot when the tide is low. However, it also makes exploring the intertidal zone much more adventurous. So this is a red seaweed, same group as nori, the kind of seaweed that you eat. And it has a really cool life cycle where it puts out its blades and grows a bunch in the winter because there's less herbivores around. And then it can do reproduction when it's less likely to get eaten. And then it kind of disappears in the spring and summer and you don't really see it.
So why does it turn green when you dry it? Is that just because the red just kind of disintegrates once it dries? Or?
Yeah, that's actually true. That's a really good explanation, way to think about it. All seaweeds, reds, browns, and greens, have chlorophyll, which is their basic pigment for photosynthesis. But reds and browns have other things we call accessory pigments that mask the green, but when you cook it or dry it, you get rid of those accessory pigments and you're just left with the green. So that's why it looks green when it's on sushi. Great point. Are these barnacles? They are barnacles. Yeah. Good spot. These are a good thing to find in the mid to mid-high intertidal. And we've got a bunch of different limpets. Got some encrusting red seaweed here. It looks like maybe the genus Hildenbrandia. Looks kind of like paint, but it's a seaweed. Look at that really big mossier hairy chitin. You can see its 8 plates really nicely, and you can touch its sort of bumpy girdle. Cool. That's a good find. Oh yeah, that's a really nice isopod. Those are they're the genus Idotea, and they live on kelp and eat kelp, and that's really cool. Very cool find. This is a blood star, but in a color I've never seen before. Kind of a red with grayish patches. Very cool find. Ooh, a sea lemon. Type of nudibranch.
Yeah, I've seen that one before.
Here we have some surf grass, genus Phylospadix, in a tide pool. You can also see some pink coral and algae on the bottom of the tide pool. This is a dog whelk, genus Nacella. These snails eat barnacles, using their sharpened tongues, radulae, to drill through the calcium carbonate barnacle shells. This is an amazing adaptation for the snail, but not such an awesome interaction for the barnacle. This is an anemone in the genus Urdacina.